Well, I've been doing some LED kit builds now for a while, so I thought I'd show you some other stuff that I also use. This is a test grid of WS2812B. These are red, green, blue LEDs. They're also known as 50/50, and they refer to the size of the LEDs being 50 millimeters by 50 millimeters. But anyway, we'll come back to those later on. This is a product called the Pixie from SmartShow. Now, I do know SmartShow. I've bought products from them in the past. Here's one here. But this is not a paid promotion or anything like that. I've actually bought this from eBay. So let's have a look at it. So what this is a small what they call ArtNet controller, which controls LEDs like this. It comes, let's have a look at the size. So it's 400 millimeters by about 150 millimeters. It's got an LED on the end, 3 wires coming out. The black wire is the ground, the red wire is the plus 5 volts, and the white wire is the data channel. It comes with quite a good comprehensive note as well. So you've got all the instructions there, both sides, but I'll show you how this works. Some items in this video I'll skip because it's going to be too long to explain, but I hope that I'll be able to give you quite a lot of information to get you going. Now, these devices come in 2 modes. First of all, you've got to set them up, connect them to your Wi-Fi, and then once they're connected, they're actually in the modes that you can use them. I'm not 100% sure whether it's waterproof or not, but I would say it's probably not, looking at the end of that, but it might be water resistant. Just get that off. Yeah, I would say it's not waterproof, no. This can be expanded though. It comes as what they call a one universe, which can control about up to 170 LEDs, and we'll look at that later on when we start looking at the laptop. So let's get this powered up, and then I'll show you how to connect. Just a quick note about the LEDs that I've got here. Now, this is just a test bed. It's put on cardboard, and I can probably hear people screaming at me now because it's a fire risk, but this is just a test bed that I've used or do use. The power comes in here, so we've got the plus 5 volt, the signal and the ground, and the power and the signal snakes, as you can see that loop at the end. Goes down there, loops that way, and then loops that way, loops that way. So this is what's called a snake all the way down. The controller here, as it comes, is a one universe, which means it'll do 170 LEDs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's what it'll do. That is what's classed as one universe, and as you can see, there's another one here which makes it 2 universe. So this is just a 2 universe test bed that I use. For our purpose, we'll only be using the 1U, which is the first half. So looking at the LEDs, we can see that we've got the copper pads here, and this is also where you can cut them. So you can cut these virtually at every single LED, and then you can resolder. They come in strips. These are 600 LEDs for 5 meters. You can get 300, which is spaced out a bit more, but I prefer to use these. And there's arrows on them as well. You can see the arrows, so it means that the data is traveling that way, and on this one the data is traveling that way. So that will go that way, loop around the end, come back that way, loop around the end, come back that way. You'll also see every meter there's a solder joint here, and again you can unsolder that, or you can cut that as well, or you can use it to what's called inject power. So I'll just explain quickly what eject power means. So injecting power, we've got the power and the signal coming in here, and it's looping backwards and forwards all the way around. We've also got another cable here, which I'll show you, just not connected to anything at the moment. So what you can do with this is plug in another power, or some more power for this, and also at the end we've got another one here. So we've got power at the start, power in the middle, and power at the end, and that just helps distribute the power throughout the whole grid. What you don't want is pushing way too much power through here, which could burn out the LEDs at the start, and having them all dim at the end because there's not enough power reaching the end as well. So you always make sure that you power inject regular intervals, and that all depends on what power you're using, 12 volt or 5 volt, the length of runs that you've got your LEDs on, and also how many LEDs are actually going to be powered as well. The other thing to bear in mind is the brighter these are, the more amps that they'll use as well. And I'll have a quick look at the ampage and how you can work that out a little later on. But for my little test bed, I don't turn the brightness up too much because I don't want to cause any heat or anything. So that's why I'm powered beginning, middle and end for my little test bed. While we're doing these testings, I'm going to use this transformer at the back here, back of my bench. This is a 5 volt 20 amp transformer, which has got enough power to power the LEDs that we're looking at, but these are the sort of transformers that you would normally use when you're dealing with LEDs. So the mains comes in here, the 240 volt comes in here, and you've got 2 grounds and 2 plus 5 volts over this side as well. So it's a little trim there if you want to just get it exactly right, but this is pumping about 5.2 volts at the moment. Just have to excuse the Xbox screws. I'm currently trying to fix an Xbox as well. So I've got the power coming off that, going to a couple of these connections here. So let's get it connected up. So first of all we'll do the red, which is the plus 5. And the black, which is the ground. Okay, I'm not going to use the signal at the moment, so what I'm going to do is just put a little bit of tape on there at the moment. I just don't want that shorting out against anything, so a bit of tape on there just to protect it. Okay, so let's power that up. Okay, so we've powered up, and the first thing you'll see is that the LED is flashing. This means that it's in a particular mode, and that mode is it's waiting for you to connect and set up the Wi-Fi on it. So let's do that now. Right, I've set up my laptop, so let's switch on the controller, and you'll see it in the bottom right corner here flashing away. So what we need to do first of all is connect to the Wi-Fi of the device itself. So there it is. The last 4 digits are the MAC address of the device itself. So yours, if you set them on these up, will be different to that, but the name will be the same. So let's connect to that. It's asking for a password. Now the password you want is actually contained within the paperwork here. So don't throw that away or anything, because you'll need the password. Okay, so that should connect us in all right. And it'll take a few seconds, because what it's doing in the background, if you're using Windows like I am, it will check to see if you're connected to the internet, because it assumes you are. Obviously we're not, because we're connected to a controller. So while it's doing that, let's bring up a command prompt. Just type in CMD and press enter. And I'm going to use a command called ipconfig. And if we type that in, you can see that we've got a number here, 192.168.4.2. That is the IP number that this device is given to my laptop. And our default gateway is 192.168.4.1, and that's the IP of the device down there. So, to access the device, we'll bring up a web page. And in the address, we type 192.168.4.1. Press enter, and there we go. So this is the setup that you'll get. So I'm going to use my trusty TP-Link router to connect to. So what we need to do is, in the ID, my TP-Link is called, believe it or not, TP-Link, as you can see. Don't forget that the name is actually case sensitive. And what you also need to do now as well is to type in the password. Now obviously the password that you're going to type in, and the ID is for your own wireless network. Because I'm using a test one, I'm using a really complicated password of 1234567 8. The IP number down here is going to be the IP number of the device once we've saved the settings and we've restarted it. So when we restart it, it'll change from 192.168.4.1, it'll change it to 192.168.0.150. You need to know really what your router is giving out as IP numbers. I know, for example, that my TP-Link is giving out the 0 range, 192.168.0. Some of them could be 1, could be 100, so you'll need to check that first. If it is 192.168.1 on your router, then you need to change that 0 to a 1. I know mine's a 0, so I'm going to leave it at that. So what we'll do now is we'll save the ID and the password. That's now been saved, and now I can tell it to connect to the network. If you want to check to make sure that the network is showing, just bring up the browser from the Wi-Fi down there, and you can see that my TP-Link is shown there. So let's connect to the network. Okay, so everything is now stopped. That's not a bad thing. What's happened now is, because we've saved the settings to the device, we no longer can see it on this range. So what we now need to do is connect to it again, but we're going to connect to it from the router. So let's do that next. Right, so now we've saved it, let's just switch it off, switch it on again, and let's see if we can see it within here. So it's not showing in here, and also you'll see that the light is not flashing either. So I'm going to connect my laptop now to the TP-Link. Oh, it is connected. It automatically connected. So I'm now connected to the router. I'm going to bring up a command prompt again. IP config, and you can see that my machine is on 192.168.0.100 and 0.1, which is the IP number for the router. If I use a command called ping 192.168.0.150, I should be able to send a test message to the controller and get a reply back. There it is. So I'm getting a reply back from that. What I'm going to do, just to show you, I'm going to switch it off. So that's the controller now switched off. I'll use the ping command again, and you'll see that it's now not working. So it's now timing out. Switch it on. And we should get a reply. So there it is. And you see that the light is now blue. So now it's saying, hello, I'm connected and everything's fine. So let's go over to the browser, 192.168.0.150. Okay, so this is now the control panel for the controller. It's happy, the light is blue. We can see that the IP number is here, so we can change that later on if we want. Remember I told you about the MAC address on the showing on the Wi-Fi? Well, there's the last 4 digits. The FBD7 for the MAC address is showing there, and that's what we're showing on the Wi-Fi. So the net and the sub and the universe are what you would use in the software for when you're talking to it through ArtNet. We'll have a look at that later on. Test 1, 2, 3 is for testing RGB, and 1, 2, 3, 4 is testing LEDs that are RGBW, which is red, green, blue and white. If we're using this in a chain of other LEDs and controllers, and we want to start our channel at a particular LED, we can use this, change the starting channel there. The unlock code is something a bit different. The unlock code is a special code that you can buy, and it will change it from a 1 universe to a 4 universe controller. There's a small cost involved with that, and that makes this a very, very powerful controller. Just to give you an idea, if we go 170 LEDs times 4, that's 680 LEDs that you can control from this little device here. Fantastic. Reboot the machine here, delete the connection, that will reset it, and a firmware update if one's available. Copyright down here, I'm on version 0.17. So that's all you can do on this. So now what we'll do is have a look at how you can set this up in some software. Right, I've installed some software called Jinx. It's free software, and I'll put a link at the end of the video as to where you can download that from. Got the controller in the corner. We are still connected to it because I've still got the config here. So what we need to do is first of all set up our matrix options. Now, because I'm only using this as a 1 universe, if you remember the matrix that we looked at the start of the video, the width of it is 17 LEDs, and we're going to use 10 lines. 10 times 17 is 170 LEDs, which it says so this there. The background grid of our LEDs is black. Everything else you can leave as the default, and you just press OK. Next thing we need to do is set up our output devices. So we need to add that in, and we're using the protocol called ArtNet. We untick the broadcast box and we type in the IP number of the controller. So 192.168.0.150. Now, if you remember on our setup, we've got a net number here, our network number set up as 1. So we need to put that in the net, just there. we're using all the channels at the moment, but you can bring that down if you want to, but for our testing we're going to use all the channels, and we press OK, and that will put the output device in that box there, and then we'll close it. Next thing we need to do is to do the output patch. So this gives an example of what our grid will look like, which is 17 by 10. And if you remember, what we said before was that it's wired as a snake. So the signal comes in, loops round, goes down to the next one, loops round, goes to the next one, like that. So if we use fast patch, we can tell it that it's 17 by 10, and you've got all different patch modes here. Currently it's set for line wise, and we need to change that, and ours is snake lines starting on the top left corner, and that's how it's going to snake all the way down. So that's the one that we need to do. The order, now this is depending on the pixels that you're using. WS2812s are actually green, blue, red is the order that they're in. First channel is 0, and the only output patch device is the one that we've got. Just to say, you'll have to check on the LEDs that you're using, whether RGB or whatever they are, but I happen to know the ones that I've got are green, blue, red. Press OK, and it patches everything for you. And what I mean by that, if you look here, we've got green is 0, blue is 1, red is 2, and if we pick up this one in the corner, you can see that it's got 48, 49, 50, and this tells the software what channel the individual colours are for that square, and it knows how to output them. So we can press close. So the next thing we need to do is we can start the output, and you can see now that the blue light has gone off. Now we're not outputting anything at the moment because we haven't got the grid connected, so that's the next thing that we need to do. Right, we've now connected the controller to the LEDs, and if you just remember, we're only using one universe, that's why the top of this is lit up and not the bottom of it. We've got the controller here, and because it's now starting to receive data, the LED light is off. We've got power coming in, we've got a couple of the connections here. This is our signal connector from the white to the grey wire. It goes up here into top, and it snakes all the way down here. We've also got power going to the end of this run here, which is the middle of the whole grid, but the end of this particular run. So I'm powering it from the top and the bottom, and that distributes the power across here quite evenly. The one at the bottom isn't connected, it's just there, which goes down there. There we go, because we're not powering the bottom of the LEDs. Now it's a couple of days later, hence the different layout of the desk, but I just wanted to quickly show you what would happen if you discovered that the colours weren't right. So I'm on simple colour on Jinx, and I'm going to turn up the red. As you can see, according to Jinx, I'm turning up the red, but blue is showing on the LEDs. Let's turn up the green, that's okay. So let's turn up the blue and we get red. So I'll show you what you've got to do with that. Okay, so you go to, first of all, make sure that the output is switched off. Go to output patch. Clear the patch that's currently on. Go to fast patch, make sure that your lines and dimensions are all right, and don't forget we're using snake lines, and it's the pixel order here that you've got to change. Now we're on green, blue, red, and we know that two of those are wrong way around, so let's change it to green, red, blue. So let's patch that. There's a bug in the program, it doesn't always work, so let's do that again. There we go. Start that again. We're on simple colour on the effects. Go to edit, go to red, and we've got red. Turn that down, go to green, we've got green, and go to blue, and we've got blue. So show you that again. Red, green, and blue, make white, and that's an auto colour. That'll just cycle through the different colours. So that's how you change if you find that your LEDs aren't showing the correct colour. And then we'll go back to the colour scroll that we had before. So what a fantastic little controller this is. Not much bigger than a thumb. It's capable of driving a lot of pixels. It's 5 volt. It uses very little power. Output is just by one cable. And you can do lots of things with it. So the cost, by the way, I bought this for £35. Absolute bargain for what you get. Highly recommended. I don't know what else to say. Really, it's if you're using it for, I think really this probably could be used for wearable devices to be controlled. One thing I like to look at in the future is doing a coat or something with LEDs on it, and something like this is absolutely perfect for that. I've got a couple of other devices here as well from SmartShow that I've bought in the past. This is the SmartShow Replay. Now the difference with this is you've got 4 outputs here, which means that you can drive up to 680 LEDs if they're RGB, the red, green, blue. Input power is 5 to 24 volts here. This is a really nice connector, so you're not messing around with wires like this, but you can screw your own connections on it. Very well labelled here, which I like, is both sides. But the piece de resistance is that you can put an SD card in and it will play pre-recorded or pre-planned patterns that you can create in Jinx. And I'll be having a look at that in a video shortly, so stay tuned for that. And then this one is, I've mounted it on this board, and this is for my big LED matrix that you may have seen a preview of on one of the other videos that I've done. Now this is an incredible 32 universe, which can drive up to over 5,000 LEDs. Power, I've created this myself, but power's on 2 cables, and there's 8 outputs on here. Driving the universes, and I've mounted this on here, and again I'm going to do a video on this later, but this is one powerful little box to drive 32 universes or over 5,000 pixels. It's just absolutely incredible. Price for this is £200, well worth every penny of it. The replay cost is £65 for that. So yeah, 3 little devices there for controlling LEDs. Oh, I'll just show you. This is something that I'm working on as well at the moment. I'll just scroll out. This is a hat with some LEDs on, got some wiring going on underneath, and I'll be using the replay to record patterns, which then I'll then be able to connect to the LEDs here. and play using this. So that's something to look forward to in the future. In the meantime, thanks for watching, and if you like the video, please give it a thumbs up.